Hey guys, it's time to talk about encapsulation. Encapsulation is, if you look up object-oriented programming on a source like Wikipedia, they'll talk about three pillars of object-oriented design. And usually they will say encapsulation, inheritance, and polymorphism are the three pillars. I would add maybe a fourth pillar, association. We're going to talk about that a lot in this course. But encapsulation is, nobody disagrees, is one of the maybe the fundamental pillar of object-oriented design. And your ability to encapsulate a class is one of the biggest benefits of designing in an object-oriented way. Okay, so let's take a look at the handout here. The idea behind encapsulation is that you do not allow other programmers or other classes to have access to the internal details of your class. So the idea is a class is a module. So a circle is a module. A circle knows about its own radius, it knows about its own location, and it controls access from outside to that radius variable and to that x and y variable. Okay, so we're not just gonna, what we have been doing, let's take a quick look at the code here. We have been just allowing, where are we? Circle main, here we are. We have been just allowing other programmers to reach inside of our circle object here and just directly set the radius. I wanted to show you that that's possible, that the dot operator can access any variable or method that's accessible inside of an object. But generally speaking, we will not do this. We will not allow access to variables like this. We're going to make our variables private so that the user cannot do that. And then we force them, if they want to change the radius value, we force them to go through methods in order to do that. And then we can control them. We can stop them from setting a bad value to the radius. If we want them to be able to read the radius but not set it, we can control that. So we can give no access to a variable. We can give read access only, write access only, or we can give full access with error checking. Okay, so if you think about, you're working in a large organization, that's always the best way to think about these object-oriented designs. And your job is to create this circle object, but other programmers elsewhere in the organization are going to use your circle object. You want to make your circle object as foolproof as possible. You want to assume, like you would with a user, you would assume that the user is going to be going to not follow your rules and do things that they shouldn't do, and you want to handle those user errors gracefully, like entering values that are out of range and so on. Same thing with other programmers. You want to handle other programmers' errors gracefully. When they misuse your code, maybe they try to set a negative radius on your circle, you want to be able to reject that and not allow it, so to not put your circle in a bad state. So that's what encapsulation is all about. And the most basic thing we can do here, if I go back to my class circle, is we can make our variables private. That's interesting. It pops up in annotation, 7 related problems to doing this. But by putting the keyword private here, I restrict access to anything outside of this class. So if I go over to circle main now, these are the related problems. I can't do this anymore. I can't have c.radius access directly like this. So what do? Well, I write what are called accessor or mutator methods. That's the kind of the technical term, but usually people call them get or set methods, or getter or setter methods. So if I want to have radius as a property, and I want to give people access to it, well, I need, if I want them to be able to read it, then I need a get method. So I can say this is a method that's just going to retrieve this variable and return it to the user. So I can go double get radius. So this is the format of a getter method. It's very standard, like that. Oops, not radius, like that. It has the same type as the variable. The naming convention is you use get all lowercase followed by the name of the variable after that, and so we use camel case for the whole thing, lowercase at the beginning. And all it does is it simply allows the user to read the radius variable. So now in here, I wonder if I could do a refactor to a method here. No, I don't think so. So what I can do here is maybe Control H. Oh, it's been a while since I've used IntelliJ. I'm not sure how to do a search and replace. Instead of looking it up on the fly, I'm just going to change this. So everywhere where we want to access the radius, it's maybe a little bit cumbersome, you could argue, but it's safer in the long run, and we'll see a lot more reasons why in a moment. So everywhere where I want to access the radius, I say get radius. And then now we need a mutator method to set the radius. So that looks like this. These methods are always void. They always start with set and then the name of the thing that you want to set. And then they need a parameter which will represent the new radius value, like this. And then I can say radius equals new radius, like that. Why doesn't it like this? Oh, I already have a set radius. I forgot that. In a previous video, I actually created a set radius method, so I don't need it. Actually, I don't need this one. Let's get rid of this one. Okay, so now if I want to set the radius, I do it through set radius. So this now changes to, instead of c.radius equals 75, it's set radius 75, like this. I keep misspelling radius. Maybe the I key on my computer is wonky. I copy this, place it here, like that. Okay, so now this code should work exactly the way that it worked before. Let's run it, and it should be just fine. There we go. So everything works the way that it did before. See previous video for what it all means. And over here, do I need to do anything here? Oh, I was already using set radius here and set location. So I have, this is kind of an Uber setter. It sets two values at once, which is fine. But the classic kind of set method would only set one of those values, would set x separately from y. And yeah, so I think I can go ahead, can I? And make this thing private too. No, that does create problems. So I won't do that with these examples. Now, what previously we haven't been specifying the level of access on things, but what we want to do typically is we want to make our variables private and our methods public. So we want to use the public keyword on all of our methods, unless it's some kind of special helper method that we don't want to be accessed from outside. So we can have a private method like this. I can make a method private. I guess over in circle.main I'm calling addup somewhere, maybe. Yeah, there it is. I'm calling addup from there. So I won't do that. I'll leave that as public as well. Initially we hadn't been putting modifiers on these variable names and on these method names. There are different levels of access. There are two other areas, levels of access. There's package and protected access. We're not going to worry about them too much in this course, but if you leave off the modifier, it's package access, meaning that anything that's inside this week 3 videos package can access it. So it's almost public, but code from outside the package can't access it. We're just going to do public and private in this course. So I've been kind of messing with this, but I want to take you to Circle 3, which is a pre-baked example. And let's go back and look at the code here. Now in the UML diagram, you can see there's new annotations here. We're going to use minus for private and plus for public. And you can see I do have a private method here. Now you use private methods when you want them to be, when you want to sort of modularize your code and make a helper method, like this distance method here. Yeah, I think this needs a return value actually, and so does this one. Yeah, I'm missing some return values there. I'll have to fix that at some point, because isInside should probably have a boolean, and distance should probably return a double. So I think I'm missing a couple things here. But yeah, so these are private, and the plus is public. I think I've covered everything in here, and then. Yeah, circle3.java. So what I really wanted to show you about circle3.java, so there's a circle3 test method here, which I think is a graphical test method. So if I run this, there we go. So it's creating a couple of circles of type circle3, and then printing them on the screen and printing out their radius and their location here. It's doing that using oh, and it's also got some output down here. I'm calling the isInside method here. Yeah, C is inside of D. So we'll take a look at those methods as well. So, but what I wanted to point out to you here is a few things. So this is now commented correctly. It's got a javadoc comment on class circle3. Each instance variable also has a comment, and it's in javadoc format as well. They're all private. And then we get into public methods, which are also commented according to javadoc format. I have an @return tag every time I have a method that returns something. Oh, by the way, there's code folding in. See, I can fold up these things here. It just changes the way they're being displayed. So sometimes by default in IntelliJ it folds things up. So this is my old getArea method, which just has a return and no parameters. And this is setLocation that has 2 parameters. So I use 2 @param tags, new x and new y, and I explain with a little single line tag here each parameter. Now, what I want to show you here is that setLocation does some checking. So this is the other big advantage of using getters and setters, is that we are really controlling access, and just because a user wants to set a new location doesn't mean we have to allow it or set a new variable value. We can reject bad values that they send us now, so we can keep our object in a consistent state. So in this case, I'm just checking if the x and y are the same as what we already have, then I print out, this is the same location. Where's my set radius? Here's my set radius. Here I actually reject a negative radius because negative radiuses don't make sense. So this isn't the best way to do it, but it's all we've got for now. Really what I should do here is throw an exception. I should create an error that then the programmer has to deal with. But instead I'm just doing a system out print line, error radius must be greater than 0. And you can see that I don't change the radius in that case, but only here do I change the radius. Error radius must be greater than 0, not changed. Okay, you might notice also here the use of a special this keyword. I'll get to that in a moment. This is the same as if I had put new radius here and then done radius equals new radius like that. Okay, so that's the same alternate syntax for that, but I'll explain that in just a moment. I don't want to get bogged down there just yet though. And then here I've got this little isInside method that checks a different circle. So that you call for this circle, you call isInside. You pass in another circle, which I call other here, and then I call it inside if the distance between this circle and the other circle is less than the radius of that circle. Okay, so if you think about it, you've got 2 circles, one big circle maybe and one little circle. As long as the distance between the 2 center points is less than the radius of that other circle, you can figure it out, but it's inside that other circle. So what I have here is a helper method. This is my public method that I'm going to allow people to call, but I have this special helper method called distance, which computes the Euclidean distance, which is x squared plus y squared, difference in x squared plus difference in y squared, and then take the square root of that. It's the Pythagorean theorem. So I compute that distance here, and I've made it private because for my own reasons, I don't want other users to be able to call this method. This is a helper method from me. So there's your example of a private method. I'm going to put this code back the way that it was before. Okay, so hopefully that makes sense. Let's go back to here. So yeah, I'm pointing out here that set radius and set location are checking their values. Oh, and the other thing to notice in this implementation is the x and y are kind of weirdly write only. You can't actually ask the circle where it is according to this setup. So radius has get and set access, so it's read and write. But the x and y's can only be set through the double setter set location. They can't be retrieved. So that's a little bit unusual, but it shows you an option that you have. And we wouldn't be able to do this if x and y were public. Similarly, we could have radius, have a get method and not a set method, and then it's read only. Okay, there is also a special method in here called toString. This method returns a string representation of an object for debugging purposes. Okay, so usually you return a string from the toString method. So basically it means convert this object to a string, and then that you print out all the pertinent information about that object. So you can see from this that it's of type circle3. You can see its radius, and you can see its x and y location. And the cool thing about the toString method is that I call it a magic method here. It's not really magic, and we'll explain later on how it works and how it's consistent with the language. But here's my toString method. So it just returns, this is a circle3, the radius is this, the location is this x and y variable. And the cool thing about it is, here I'm printing them out here. So in circle3 test, where are we? Here we go. I just print out, I didn't actually call the method. I just print out system out println C, and it prints that. Okay? This triggers a call to the toString for that method and then calls it. So if I change this toString to something else, let me just change it slightly, radius equals that, and then rerun circle test 3, you'll see that the output has changed because I've changed the toString. But I didn't have to change anything in the code over here, and nowhere will you find a call to the toString method here. I believe I'm also using concatenation here, so it also works in concatenation. So if I want to, let me just, so you can see I'm also putting the two strings up here. And I'm doing that, I can't, in this context, I can't do this. That won't work. You can see it's a syntax error, but I'm using a little trick here. I can concatenate C, the circle C, onto the empty string, and that will trigger a call to toString, and then I end up with basically the same result there. This is a good little trick in fill text. If you want to print out, say, an integer or something like that, you just concatenate whatever it is you want to print out, concatenate it to the empty string, and it will do the automatic casting or call the toString method and convert it to a string for you. Okay, so that's what I'm showing here. You know, if I create a string my circle colon and then concatenate circle on, it will call the toString method, which returns a string and puts it there. Now I want to show you a couple more things. Let's go back. I'm going to start a new object here. In fact, let's recreate the object on the next page here. So this is a rectangle object with a width, height, and an area. Okay, so I'm gonna use that as an example. So I'm going to create a new Java class called rectangle. Make this a bit bigger. So a rectangle has private double width, like that. All right, let's make these integers, just because we've been dealing with doubles a lot. And we've got a private integer height, and we've got a private integer area. So I think this is going to be a little bit different from the example in the book there. So I create my class rectangle. These are my three variables, and maybe I want to create setters and getters for all of these variables. Well, I can do this like this: Alt insert. So that's the key combination. I think it's probably on a menu over here somewhere as well. There it is, generate. So we're going to generate code, Alt insert, and then I say, okay, I want getters and setters for all three variables. Boom, there they are. So it automatically generates that code for me. Why? Because we create getters and setters all the time. And they're you know, this is just standard boilerplate code. So it goes ahead and creates them for us. And it's doing this thing in the setter method that I pointed out in circle 3 and changed. So what we've been doing is we've been doing something like this: new width, and then width equals new width, like this. That's not really the standard way to do it. It's a little bit cumbersome to have the variable called new width. But the problem is that we couldn't call the variable width, because then what we end up with is a local variable called width, and also a class variable, an instance variable called width. And because the scope of this is smaller, so the scope of this variable, if you remember the scope rules, it's visible entirely inside this block, inside the class block for rectangle. This one is visible just inside this block, and when you have two variable names that are the same, like that, the one with the smallest scope wins. So these references to width are references to this variable here, and you can see IntelliJ is pointing that out. Whereas when I had called this one new width, like this, now you can see that new width is this variable and width is this variable. But what the way that IntelliJ constructs the setters is it does it like this. It allows you to use the same variable name here as the instance variable. So this reference to width refers to this variable. And then we're using a special magic variable name, I'm calling it magic again, this. So notice it's blue. It's a keyword in the Java language. And you can think of it as a magic variable that's always there that actually holds the reference to the current object. So when I say this dot width, I am actually accessing the width instance variable. Whereas if I just say width, I'm accessing this variable here, the local variable. So this is actually really, really standard, and this is what most programmers do when they are accessing instance variables, is they use the this keyword, and they name the variable coming in for the setter the same as the instance variable. So you can see all the setters are like that. We pass in a variable with the same name as the property we want to set, and then we use this dot height to access the property. Okay. Now these, when you use alt insert to create these getters and setters, and you don't have to create all getters and setters. You can, so for example, if I wanted just a getter and just for area, then I could do this, alt insert, just give me a getter, just give it to me for area. So I can choose the variable, and if I think control click, I can choose multiple ones. So I just click area, and then I just get a getter for the area. And then alt insert, I want just a setter for height. Okay, and now I've got a setter for the height, and so on. So this, they may not do everything you want to do though. So this, if we wanted to create some checking here, we would have to do something like this. If height is less than or equal to 0, you know, system out print line, bad height. And then here's a little trick I could do. I could just return directly here. So I don't, that exits and bails out of the method right here and doesn't go on and do the set. So yeah, so we disallow it. So that stuff you have to add yourself. There's other things you can generate here as well. See, the first one on the list is constructor. We're going to look at constructors next week. But toString is one that you might want to add, like that. And you can say in your toString, which of the variables would you like to print out? By default, it's selecting all of them, but you can say, actually, I only want to show the width and height in my toString, or you can show all of them. And then you say OK, and it gives you this boilerplate basic toString like this that returns rectangle plus the width, height, and area in curly brackets like that. Okay, so you can do some automatic. So two things in that last little bit that I told you about rectangle is that we're using the this keyword now, which is this magic quote-unquote variable that's always there and refers to the current instance. It allows you to have a local variable with the same name as an instance variable. And then you can use this to specify whether you're referring to the instance variable or to the local variable. And I also showed you this little tip here, alt insert, to automatically insert getters and setters. Okay, so that's it. That's encapsulation. We make our variables private. We make most of our methods public. And we use getters and setters to control access to the internal details of our object. And now we want to go back to the object that you've been working on, the class you've been working on, and I want you to encapsulate it. Okay, so on your UML diagram, you put minuses and pluses to indicate whether things are private or public. And then you write a toString. I want you to write a toString method and add getters and setters, and you should decide, and this is up to you, think about it, what get and set methods are appropriate. You know, are there things that you don't want the user to be able to set, or things that you don't want them to be able to get, or just add them all if you think that that's most appropriate. And then every method that has parameters, so every method that you previously wrote or every new setter method, implement boundary checking to make sure that they can't put your object into an illegal state. So for bank account, for example, you shouldn't be able to deposit or withdraw a negative quantity. Names and IDs can be changed, but you should implement some formatting rules and so on. Squares can't have a negative size or an off-screen location. They can't have null colors, whatever. I mean, exactly what you do is going to depend on how you design the object in the first place. Here's an interesting one. You know, the TV can be on or off. You can't change the channel while it's off. So if you have a setter for changing the channel, or an increment or decrement for the channel to simulate the plus and minus buttons on a remote control, they shouldn't function if the TV is in the off state. and so on. Students can't have negative grades, damage and healing can't be negative, et cetera, et cetera. Okay, so that's your next step. Give that a try, and in the next video, I'm just going to talk about a concept that's important, which is separating the interface from the implementation, which is kind of what we're doing now, but we're going to talk about it more explicitly and some of the benefits of doing that in the next short video. See you there.